Green Network xDSL technology, NeXT. Our networks are segmented into core, edge, aggregation and access network. Access network is the biggest segment of a telecom network, connecting the telecom central office with end users. The global demand for bandwidth growth has increased unprecedentedly, and energy consumption follows the same trends, which increases OPEX for telecom operators. One thing in our mind: how much bandwidth can we deliver? Unify service over fiber to the home or FTTH offers higher bandwidth. However, majority connected to 5 megabytes per second due to the issue of affordability. Almost 44% of wireline subscribers are connected to below 1 megabyte per second due to the network issue. The next question: what would be our customer experience? Unfortunately, our average subscriber's bandwidth is below 5.5 megabytes per second. How much energy do we use? How fast can we deliver it? What will be the cost? We have deployed 68% copper access network. It consumes a large portion of the energy consumption. Due to the long copper distance, this has resulted in low bandwidth and high energy consumption. We have invested more with the copper access network. Visualizing this matter is important for the solution. What if we could give more value for less? NeXT provide the solution. Current trends. Operators are deploying the FTTH to offer high bandwidth, but it takes a longer time for deployment, and the cost will multiply when it reaches the customers. This will result in a longer ROI. Traditionally, ADSL Plus covers long networks of up to 3.5 kilometers. Using a single monolithic MSUN or DSLAM enables a large customer reach. However, it runs in large bundle copper that will create crosstalk, thus offering low bandwidth. The use of VDSL2 ramps up the bandwidth. However, VDSL works with shorter length loop, thus limiting its reach to customers. Leveraging on the existing large copper access network, how do you get more from our copper network? What are the steps involved in getting to the next level? Bandwidth is a function of distance, and energy is also a function of distance. By bringing our nodes closer to the customers by using fiber as an uplink, we can get high bandwidth and lower energy consumption. Further improvement: allowing the VDSL2 or vectoring will offer higher gain in bandwidth and greater reduction in energy used. We configure very large to very small equipment form factors, allowing service providers to install system equipment based on user density. To serve the high-density users, we use NeXT Model 1, which supports 200 users. To serve the medium-density users, we use NeXT Model 2, which supports 48 users. To serve low-density users, we use NeXT Model 3, which supports 8 users. Now, we introduce remote powering using the existing cabinet. For high-density equipment, we use forward powering, and for low-density equipment, we introduce reverse powering from customers' premises equipment. These would reduce the number of power cabinets needed for the node. We are also designing tools that service providers need, which can increase operation efficiency. By selecting the area, we can perform analysis on the current selected network. We can also do planning for both brown and green fields for intended deployment. The optimization engine allows us to optimize networks for bandwidth performance and energy efficiency, as well as quantify to fit the user density equipment deployment. What is the benefit of bringing nodes closer to the customer? Reuse last-mile copper, less digging and trenching, 40% less cost than FTTH, 5 times faster than FTTH, shorter payback time. NeXT provides the solution.